we need to find the volume of the region bounded by the paraboloid x² plus y² equal to az and the cylinder x³ plus y² equal to r square. In this diagram, this is your cylinder with equation x³ plus y² equal to a square. But in our case, the radius is capital R. So please take this a as capital R. So this is the cylinder with equation x³ plus y² equal to capital R square. And this is your paraboloid with equation x³ plus y² equal to az. In the xy plane, the z is 0. And this is your small r. So we are going to use the cylindrical coordinates here, where x is r cos theta and y is r sin theta for the cylindrical coordinates. And given paraboloid is x³ plus y² equal to az. Let's put the value of xy over here, taking r square common. So this is 1 equal to az and r square is equal to az. So from here I can get z as r square over a. So the limits for the z can be, so here if you notice that in the xy plane z equal to 0, which becomes the lower limit, and it is at this curved surface, the z is r square over a. So this is r square over a. So limits of z will become from 0 to r square over a. And the equation of cylinder is x³ plus y² equal to capital R square. Let's put the value of xy here also. So this is r square cos square theta plus r square sin square theta is equal to capital R square. So this is r square is equal to capital R square. And from here I get the positive value of small r as capital R, which means the small r is equal to the radius of the cylinder. And now the required volume is by symmetry. It is of course 4 times the volume in the positive octant. And the limits of z are from 0 to r square over a, right? And limits of r is from 0 to this capital R. And the limits for theta is, because it is the positive octant, so the limits are from 0 to pi by 2. So let's calculate the required volume now, which is 4 times the volume in the positive octant, that is r dz dr d theta. So limits for z 0 to r square over a, and for r it is 0 to capital R, and theta is 0 to pi by 2. So integrating the innermost integral with respect to z, we get rz. So this is 4 0 to pi by 2, 0 to r, and this is rz, limits 0 to r square over a, dr d theta. So when you put the limits over here, we get r cube over a minus 0. So this is equal to 4, 0 to pi by 2, 0 to r. This is r cube over a, dr d theta. And then integrating with respect to r, we get, this is r4 over 4a, and the limits from 0 to capital R d theta. So this is 4 times r the power 4 over 4a minus 0 from 0 to pi by 2. And now all these are constants, taking outside, this will cancel out. This is r the power 4 over a, and this is theta 0 to pi by 2, which is equal to r the power 4 over a into pi by 2, which is pi r the power 4 over 2a.